Okay, so today we're going to talk about how to write the equation or the function if you're just given the graph. Okay, so just don't even think like, oh my gosh, is this sine or cosine? Don't worry about that right now. I'll go over that in this video. The very first thing that I want you to look at is, what do you observe in this picture? So give me some observations that you have in this. Yeah, someone says, hey, Ms. Johnson, I noticed that it moved down a bunch, right? And you're going to tell me how much did it move down. So normally it is here. Normally your midline is here at 0, right? And now your midline moved like all the way to the bottom, like moved it down a bunch. So I need you to calculate your midline, like the middle of the graph. So a bunch of people said it. So I'm going to write it right here. The midline is equal to -30. I should put y equals to -30, right? And how do you know that, Ms. Johnson? Because look, the middle of that graph is hitting around that y equals to -30 line, right? So that's the very first thing. And if you're paying attention to like the variables that we used before, if this is our function, he was at the very, very end. And I think we used him as the letter D. So I'm going to put -30 right under there. Okay, so there's this like function-y thing, and then there's this -30. He goes at the end. What else do you guys see? Oh, very good. Some people say, hey, Ms. Johnson, I see the amplitude. If you don't know what the amplitude is, it's from midline to the highest part. So this is what I'm going to write as my amplitude. And he's the letter A for amplitude. Isn't that nice? Okay, so what is my amplitude in this case? Be careful, count carefully, because I don't give you enough numbers, but you guys can see it. Someone says, is it 15? And let me see if that makes sense. So from 30 to 20, that's 10. And then it looks, is that halfway in between? Yeah, that looks halfway in between 20 to 10. So yeah, it's 15 because it's 10 here plus 5. Another way for you to calculate mid amplitude is highest minus lowest divided by 2. So the highest looks like that, lowest looks like that, divided by 2. Or you could go from highest to midline. So this looks like it's -15 minus -30, and I'll write that down so that you guys can see that. -15 minus -30 equals 15. So for those of you who just count, like you're good at counting, good. But for those of you who like to verify things like I do, then I'm going to go with highest minus midline. Okay, so that's 15. If you remember where 15 went all the way out in front. For some reason, your book is using a capital A, so I'm just going to use that. So that's 15. And if you remember, he sat right in front of sine or cosine. He sat right in front of sine or cosine. So I'm going to put sine. That doesn't look like sine. Cosine, whichever one you're using. Okay. So I'm going to pause on explaining sine and cosine right now because I want to get to our last one, which normally it takes like if you remember Carlos, like how long did it take him to go in a complete cycle? That's what we're going to calculate next, right? How long does it take to complete a complete cycle? So from here, I start at 0, I'm at the top, and I go all the way down to the minimum, and then I go all the way back up to the maximum, and that's a complete cycle. A complete cycle, like if you want to think about it, is like if I took a picture from here all the way to here, it just repeats itself again and again and again. So like Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. It repeats itself, right? So how long is it taking for us to complete a complete cycle? How long is it taking for us to complete a complete cycle? Yes, it's 4 units long. So if you don't know why the 4 units is 4 units long, so if you kind of like make this guy go all the way up to the top here, right? What number is that? And so someone says, oh, it's 4, Miss Johnson. You can figure out why it's 4 on your own. I'm not going to bore you with that detail. But yeah, it's 4 units long. So normally it takes 2 pi, because that's what a complete cycle is. It's a complete circle. One circle is 2 pi. But now it's taking 4 units long. So here's my little equation that I want you to look. So they multiplied 4 by something, and then that's how long it normally takes me to complete a whole cycle. Does that make sense? So you want to solve for P, and P is the one that sits right here in front of your X. So let's put our X down, and then P goes right there. What color is P? P goes here. So does that make sense? So I am looking for my coefficient for X that goes in front of that X. So if I solve this here, what do I get? If I solve for P, what do I get? Yeah, so divide by 4, I get P equals to pi over 2. So that's what my P is. I'm going to put pi over 2 here. Ms. Johnson, I don't see pi over 2 in my picture. That's right? Because pi over 2 used to tell you how much of an angle is covered in a second, right? So if pi over 2 is covered in a second, how long is it going to take me to complete a full circle? How long did it take Carlos to go all the way around the Ferris wheel? So you're like, well, pi over 2 is like 90 degrees, right? It's like this much of the circle. If this takes 1 second, right? How much is it going to take to go all the way around the whole thing, right? So you're like, oh, it's going to take 4 seconds. So that's why up here we have this 4. Does that make sense? Okay, so the last thing that I want to look at is I want to figure out if it's sine or cosine. Now, I said this in another video, but I want to share it again. So in my brain, I'm going to scooch this up here. Sine looks like an S. So it starts at the middle, goes up to the top, goes to the middle, goes to the bottom, goes to the top. Take your head, turn it sideways, and just imagine, do you kind of see an S flow there? Kind of like this. So that's what I see. I don't look at the whole thing. Like looking at this whole thing, that whole graph is confusing. So I just look at one cycle. So sine of X looks like an S. Everybody okay with that? Versus cosine starts at the highest, goes to the middle, goes to the bottom, goes to the middle, goes to the bottom. Okay. I'm just going to make sure that we all connect things just so that it's all in one nice, neat pile. So, Ms. Johnson, how did you know that it starts in the middle, goes to the top for sine, goes to the middle, goes to the bottom, goes to the middle again? So I want you to pretend you are watching Carlos go on the Ferris wheel. Okay? You're watching Carlos go on the Ferris wheel, and you're just watching him go one time. And of course, Carlos starts at 0, right? So when we're talking about sine, which coordinate are we talking about? When we're talking about sine, which coordinate are we talking about? Very good. So now, don't look at Carlos as in x comma y. Look at him in just terms of y. So when we start him off here, he's at the middle of the Ferris wheel. And then in a little bit, he's at the highest point of the Ferris wheel. Middle, low, middle. That's why this is middle, high, middle, low, middle. Does everybody see that? Your brain is supposed to go like, wait, what? So if I can point at 2 things at the same time, well, if I can have you point at 2 things at the same time. So I need you to point at where Carlos is here. That's where one of your fingers is going to go. And this is where Carlos is here. The difference between these 2 things is over here, he's on the Ferris wheel. And here, this is linear movement. Not linear. This is time. This is like, sorry. This is a graph of his height over time. No, it's not a roller coaster. Don't think about this. Don't think about sine as a roller coaster. Think about this. This is his height over time, meaning how high Carlos is in a, like, if you like were to like put a like time lapse him, and the only consideration I was going over was height. Yeah, you can kind of think about that. So there's actually a really good graphic I need to find to show you guys, but I will show you that later. Okay. So put your two fingers at there. Okay, now make Carlos go around the circle and get to the top of the circle. So now your finger should be here. But where should your finger be on the height over time graph? Here, right? So that makes sense because you're at the highest point of this circle of the Ferris wheel, and now you're the highest point of his graph. Does that make sense? And then you continue, Carlos, and he's at 0.3. Now he's at 0.3. He's in the middle again. And then continue. Oh, he just passed the bottom. So he's here. Do you guys all see how these match up? These are matching points. Very good. And then now you're here again. But yes, you're back again, and you're just going to go through that cycle again. So if you think about why this is cyclical in nature, it's because Carlos keeps going around the circle and his height keeps changing. Does that make sense? Similarly here for this one, now for cosine, I just want you to pay attention to x, like his x number. So he's the rightmost. He's the rightmost here. He's straight in the middle. He's the leftmost here, straight in the middle, and then back at the rightmost. So for now, for our purposes, just know that cosine looks like a V and sine looks like an S. Okay. You'll make this connection later. Some of you got it. I'm okay with not everybody getting it right now because this is our first time. All right. So which graph is this? I know this looks like a mess, but if you're looking at this, you shouldn't be looking at everything. You should be looking from 0 to 4. You should almost like it should be like tunnel vision where you can only see, oh, let's do green. You can only see this green part right here, right? Yeah, he has to be cosine. He has to be cosine. Okay. So then I'm just going to write cosine in here. So this is cosine here. And there's my function. Cosine of 15 cosine pi over 2x minus 30. And I'm just going to add a parentheses here to grab all that. Okay, so which is the hardest part here? I think finding the midline, you guys are pros at. I think finding the amplitude, you guys are pros at. I think this is the part right here that needs to be in your head, which is, it's just the formula 2 pi equals to 4 p. Where did this 4 come from? Where did this 4 come from? Where'd that come from? Yeah, it's where, or actually I won't say it like that. It's how long it takes to complete one cycle. Sorry, let's put period or cycle. If you want, circle. It's one of those. However, it makes sense to you. So here we went from top. I'm highlighting in green again. We went from the top all the way to the bottom, all the way back up to the top, and then we would repeat, right? So that means it took me 4 units long. So that's where that comes from. So Miss Johnson, like, let's say that, it was, oh, actually here, this one up here, if you look, why is this 2 here? Why is that 2 here? Yeah, 1 full cycle. Mm-hmm. Yeah, that 2 is because it took Carlos 2 seconds long to go all the way around the Ferris wheel. That Ferris wheel is going really fast, right? So is everybody okay with this? Okay. The next thing So the other part that is going to be a little bit on the wait, what side is knowing the difference between, oops, I was erasing. Knowing the difference between sine and cosine. So if there's a place that you need to make sure that you're comfortable with, it's going to be those two places. Because I think amplitude, midline, you guys are all comfortable with because we've been talking about functions for so long, right? All right, very good. Thank you for listening.